Okay, in this lecture, we're going to talk about polynomials. And the polynomials, as you recall, are expressions that are made up of terms that are in this form. The form is ax to the n. Okay, so if I have an expression, I'm going to use px as a polynomial in x, and expression something like, for instance, 3x squared plus 5x. That would be example of a polynomial. The key is that every term, that's what we call, these are called terms of the polynomial. So I have a term here and a term here. Each of these terms must be in the form ax to the n, where it's important n is a positive, let me just say whole number. How's that? N is a whole number to make it easier. N is a whole number. And remember, the set of whole numbers is 0, 1, 2, and so forth. So for example, 3x to the 7th. 7 is a whole number, so that qualifies as a term of a polynomial. So a polynomial, again, is an expression, a mathematical expression that is made up of a finite sum or difference of terms that are in this form, ax to the n. And that's what a polynomial is. Now, the term of the polynomials could have the variable x in it, or let me make up another polynomial. Could be as simple as x plus 5. Now you may wonder, well, how does 5 look like that, right? Well, I can write 5 as 5 times x to the 0 power, because anything non-zero to 0 power is 1. So that's 5 times 1, and that is 5. So there we have it. Therefore, 5 qualifies as a term of a polynomial. Okay, so this is what we call a polynomial in x. I could have a polynomial p in m. This one is going to be m squared negative 4. That's a polynomial in m. Okay, now if a polynomial, because the prefix poly means many. Okay, so polynomial literally means many terms. Nomials, terms. Polynomials means many terms. Now, if a polynomial has only one term, well, there's not that many terms when there's just one. For example, 3x to the 8th power. Because it only has one term, then we call this more appropriately, a mono, meaning one, monomial, one term. If a polynomial, let's say in x, is x squared plus 4. This time, the polynomial has two terms, so we call this a binomial. Bi meaning two. Okay, and we have a binomial. If the polynomial in x has three terms, like x cubed, negative 4x minus 2, this one is called a trinomial. Now, beyond mono, bi, and tri, 1, 2, and 3 term polynomials, we simply call these polynomials. So if I have 4 terms, they don't have another name for it. They just call it a polynomial. Now, as far as the term is concerned, if we look at, for instance, let me make up an example. Let's say the expression that I have, a polynomial in x. Suppose it's going to be x to the 5th, 2x to the 5th, negative 4x squared plus 7. Okay, now every term of the polynomial has what we call a degree. The degree of a term in a polynomial is the exponent. Exponent on variable that we are working with, the exponent. So for example, 2x to the 5th, the degree of this term is 5. Here's the degree, 5. The degree of x squared is 2. The degree of the constant is 0. because again, you can write it as 7 times x to the 0 power. So those are the degrees of each of those terms. Every term also has a coefficient. Now, by the way, if I have a term such as 11x, what's the degree of this term? Well, the exponent on x, if it's not written, is 1, so the degree is 1. Okay, just to put that out there. Now, we talked about the degree of the term. Let's talk about the coefficients. The coefficients are the numbers that multiply by the variable, the coefficients. So the coefficient here on x to the 5th is 2, on x squared is -4, and the coefficient on 7 is just 7 itself. The constant, the coefficient is itself. All right, now, having talked about this one, let's see, what else we want to talk about? Well, I guess next we could see how we can add, subtract, multiply, divide these polynomials, right? Oh, the one last thing I want to talk about is the degree of the polynomial. Degree of a polynomial. Just as a term has a degree, the whole polynomial itself also has a degree. So the degree of a polynomial here would be, this would be same as the highest degree term in polynomial. So if I, let's make one up for this one. Suppose my polynomial is 3x to the 10th negative 2x4 plus 7x. Well, the highest degree term is this one, the first term. So the degree of this polynomial is 10. This is a 10th degree polynomial. And as you notice by now, we usually write polynomials either in descending powers of x, x5, x4, x3, 2, 1, like that, descending powers, or sometimes they write them in ascending powers, usually in like statistics textbooks and in multivariable regression. They usually do that. Those regression models, they write them in increasing order. Okay, so it doesn't matter. For most of the work that we do, we're going to stay with decreasing powers of x. Decreasing. So this is the form that I'm talking about. Okay, and there we have that one. So we've talked pretty much all we wanted to talk about, the polynomial itself. Now let's see how we're going to, let's say, add, subtract, and multiply these polynomials. Okay, now multiplying polynomials, we have actually some special products that you may recall. So let me talk about these special products, multiplying polynomials. Special products. The special products that you have probably seen before are like this. If I have x plus y times x minus y. So here I'm multiplying the binomial times a binomial, and well, I guess before I look at the special product, let me put this one on hold. Let's say we're going to talk about multiplying polynomials. So the easiest case is when I'm doing a mono times mono. That means a monomial times monomial. So for example, 3x to the 7th times 2x squared. You simply multiply 3 by 2, the coefficients, and multiply the variables. 2 plus 7, 9, using the product rule of exponents. So that's multiplication of a monomial times a monomial. If I have a mono times a binomial, so that would be like, for instance, 5m times m squared minus 4. Well, to do that one, we use distributive property. So I'm going to do 5m cubed negative 20m. And that's how we do monomial times binomial. Now, I could have a monomial times a polynomial. Just anything beyond a binomial. For this one, let's say I'm going to do 2x times x fifth negative x4 plus 3x plus 7. See that? That one has 4 terms. And note, by the way, some of the lower degree terms are missing here, like the cube, the third degree, the second degree terms are missing. So those will be simply discarded or ignored. Now, to multiply a monomial by a polynomial, we do extended distributive property of each of the monomial by each and every one of the terms in the polynomial. So for this one, it's going to be 2x times x to the fifth. That's 2x to the sixth. And then we do negative 2x times x4, negative 2x fifth, plus 6x squared, plus 14x. And there you have it. So it's pretty easy. Monomial times whatever kind of a polynomial it might be. Now the case where we have, let's say, a binomial, like this one, a special product that we're about to talk about. Suppose I'm doing a plus b times a plus 3b, something like that. So to do this kind of a product, a binomial times binomial, you really do extended form of the monomial times binomial. So what I mean is this: you multiply a monomial times a binomial. It's just like that one. And then we need to do that with b. b multiplies by a and 3b. Therefore, a makes a squared. A times 3b, that's 3ab. Plus AB, I'm doing this one now. ABBA, there's the same thing. B multiplies by 3b, that makes it 3b squared. And there you have that one. Now we can combine like terms if there are any, which in this case there are. Like terms, by the way, are those terms that have exact same variables but possibly different coefficients. These two terms are like terms. They have the same variables. So I have 3ab and another ab. That's a total of 4 of the same thing. They're alike. And there you have it. So this is how you multiply a binomial times a binomial. What if I'm multiplying, let's say, x cubed minus 2 times x squared plus x plus 5. This time I'm doing a binomial times a trinomial. Again, we can extend what we just did. We can multiply first term times trinomial, and then the second term of the binomial times the second polynomial. So first times first, that would be x to the fifth, right? Cube times x squared, that's x to the fifth. Times then x cubed times x, that would be x to the fourth. X cubed times 5, that would be 5x cubed. Negative 2x squared. Negative 2x minus 10. And there you have it. I multiplied negative 2 by each of those. And once we do, then oh, this is nice. It just happened. It worked out nicely. It's naturally in descending powers of x. And there are no like terms, by the way, in here. Look at these two. They're both negative 2, but this is x squared and that is x. So they're not the same thing. They must look on the variable side. They must look identical. So there you go. That's as far as that one goes. So this is how you multiply them. Now I can do the special product. If I carry on the special product, and actually let me just erase it here and write the special product, because these special products, there's usually 3 of them that we talk about. So I can fit them all on one spot. Special products. These special products are when you multiply a binomial times another binomial. Okay, now these 2 binomials are kind of special because notice one is plus, the other one is minus. So we call these conjugates. So one is conjugate of the other. A conjugate of x plus y is x minus y, and vice versa. So we can distribute, do x and xy, x times x minus xy, and then do y times x, y times y. I'll make it x squared. The 2 middle terms are opposites, they add to 0, so that's going to be x squared minus y squared. And you probably recognize this. This is a special product that actually has a name. They call this difference of squares. 2 squares, some call it squares. So difference of squares. It's a special product, yields difference of squares. Okay, and there we have it. Now when you do a binomial times binomial, by the way, you probably have heard of the FOIL method of multiplying binomial. That's a common acronym they use. Now the FOIL, this is some kind of a memory aid. It's supposed to be that. It only works in English because I'm sure in other languages FOIL doesn't necessarily translate as nicely as it does for us. The first letter F is of the word first. O stands for outer. I stands for inner. And of course L stands for last. So this is a reference to, let's do this, a plus b, a minus b. So with respect to the position a, b appear in the 2 binomial, these are the first 2 terms, right? So there's f. So we multiply a times a. Notice I just changed my xy to a and b. So but I'm doing exactly the same thing I was here now. And then the O stands for the outer terms. Well, the relative position of terms with respect to each other. Those are the outer terms on the outside. Negative a times b, that's negative ab. The relative position of b and a in here, those are the inside terms. Call them inner terms. They multiply. And finally, last in the first binomial, last in the second binomial, they multiply together, giving me negative b squared. So we end up with the same expression. You see that? So if you're into that acronym FOIL, you're probably used to it. That's fine. You can continue using it. Just want to clarify that's what that is, and a lot of people are familiar with that. So we saw our first special product. Now let's take a look at our other special product here. The other special product we have is, what if a binomial multiplies by itself, not the conjugate, but itself? In other words, this is x plus y squared. Again, we can FOIL things like I have here. We can FOIL them together. And when we FOIL them, this is f, here's the o, here's the I, and here's the L. Turns out the OI are like terms, so I got 2 of the same, plus y squared, and there is a special product. So keep in mind when you do, let me just write it now, when you do x plus y squared, we don't just get x squared, plus y squared, right? You square this one, you square that one, but you also have twice first by second. Now, to make that impression, just to emphasize the middle term, this is very important. You square a binomial, you're going to have three terms as you just observed. First one squared, second one squared, twice first by second. Now, if this is a minus, by the way, the only difference would be if there's a negative here. Negative here. Let me not do it over here. But in here I can do it. If it's negative here, then the middle term would be negative in here. The x and y still be squared on the first and the third term, but not in the middle term. Okay. And there we have these special products. Now, because we can write, if you think about it going in this direction now, because we can write these trinomials, three expressions, as a square of a binomial, is what these are. Trinomial, square of a binomial. For that reason, we call these perfect square. These are perfect square trinomials. And the reference to, like, why is it called square? Well, we can see it's square because of that. And what's so perfect about it? Because, again, if you think about in terms of the geometry of this thing, you have a perfect square. There is a square whose side is x plus y times x plus y. So this will give you like the area of that squared. The product will give you the area of the square. And we have that one, perfect square trinomial. Okay, I'll do example of these in just a moment. I just want to make sure I cover the basics here. And there you have it. So these are just review of polynomials like we did in algebra class. We will be using these throughout our college algebra topics coming up later on. So I guess next we're going to see how we can actually how we can actually add, subtract, multiply, and divide these polynomials. That's what we want to do. Okay, so let's do this then. First, review of polynomials. First of all, I want to know, for instance, if this expression 3/5 x squared plus 1/2 x plus 3/4, is this a polynomial? Can I say that's a polynomial? Remember, the definition of polynomial was terms that are in the form ax to the n. A is any real number. It could be positive, negative, fraction, decimals, radicals, anything. So the fact that these are fractions in front, no problem. Also the constant in the end, the 3/4, that's fine. Each of the terms, here's x squared, yeah, looks like that. X looks like that also. So both of those are fine. Therefore, this is a polynomial. Is it polynomial? Yes. Now, what's the degree of this polynomial? This is going to be a second degree. Degree is 2. This is a second degree polynomial. Okay. Now, how about something like this? What if I have 3 over x squared plus 5x minus 2? Is this a polynomial? Because the question is right in here, right? The fraction, the variable is in the denominator. So let's rewrite this first fraction as a negative exponent. It's going to look like that. Remember, n has to be a whole number. That means 0, 1, 2, and so on. Well, look at the exponent here, negative 2. Negative 2 is not in that set. It's not in the set of whole numbers. So, sorry, it doesn't work. Therefore, this one is not a polynomial. Again, the reason it is not is because of that negative 2. The exponent on the variables have to be 0, 1, 2, 3, 4 like that. They cannot be negative numbers. They cannot be fractions. They cannot be radicals, things like that, unless they reduce or simplify to a whole number. Okay, so that's not a polynomial. And we got the degree. Of course, it doesn't make sense to say a degree because it's not a polynomial, so we cannot say it's a second degree, whatever. Doesn't qualify even. Now, let's do some basic addition, subtraction. Add, subtract. Okay, so suppose I want to do something like this. Let's say 6m for negative 3m squared plus m. I'm going to subtract another polynomial. I'll make, let's say, we're going to call that 2m cubed plus, let's go 5m squared plus 4m. And just to throw another one, let's add m squared minus m there. And we just want to add, subtract. That's all we want to do. So let me rewrite this. First, subtraction. There's 6m for negative 3m squared plus m. So I'm going to distribute the sign. When we subtract a polynomial, we subtract each term of that polynomial. So I'm going to subtract 2m cubed, subtract 5m squared, subtract 4m, and then add the last two terms. Now here is where we want to look at like terms. Fourth degree term, that's the only fourth degree term, so I'm going to write it. Next we look at third degree terms, there's only one. Then we move on to second degree terms. That's this one, and this one. Okay, and these three like terms add to negative 3, negative 5, and 1. That's negative 8 plus 1, negative 7m squared. Once we have that, then the last one is just m, and m. Those are like terms, correct? These m's. So we've got an m here. Subtract 4 here, I get negative 3 and negative 1 more, that's negative 4m. And we were able to combine these these terms. So that's how you simply add or subtract them. Pretty straightforward addition and subtraction. Let's do a product. Multiply. So to multiply, suppose we have x squared times 3x minus 2, and then times 5x plus 1. This one. No, we can do multiplication in any order, right? The associative and the commutative property of multiplication. We can rearrange these. So one thing I could do, for instance, I can multiply these two, and then the result gets multiplied by x squared. Well, let's do that. Now, when I multiply this binomial times this binomial, we can FOIL them. And when we FOIL them, 3 multiplies 3x by 5x, 3x by 1. So that's going to be 15x squared plus 3x. And that's the first distribution. The second distribution, which is the IL in FOIL, that's negative 10x and negative 2. Okay, got that one. So this would be x squared, 15x squared. Like terms, these two are like terms. That's negative 7x minus 2. And next we can distribute x squared to that trinomial, becomes 15x4, negative 7x cubed, and negative 2x squared. And there we have that one. So we were able to multiply these together. Let's look at another product. Let's say conjugates again. Remember, when we multiply binomials that are conjugate, the result will be difference of squares, right? So you can FOIL it, FOIL, or I can just do difference of squares. Difference of squares means you square the first term, you square the second term. This will be a shortcut. The answer is 4m squared minus 9, rather than doing FOIL. Now, if I have something like 4m plus, I don't know, 2n quantity squared, again, I can set it up as FOIL and do FOIL, or I can recall a special product. There, repeated multiplication. 4m plus 2n squared means 4m plus 2n multiplied by itself twice. The special product would be this one. So I can use that or simply FOIL them. So if I do FOIL them, I'm going to get FOIL like that. So that's going to be 16m squared plus 8mn plus 8nm. I'm doing this one now. And then 2n makes 4n squared. All right, and now we can write this as 16m squared. The middle terms 16mn, last one is 4n squared. And there we have it. And that would be the result of multiplying them together. Let's see, another one I can make up. How about, let's try something like this one. Suppose I want to do, again, another multiplication. Let's do something with, again, maybe rational exponent. So I'm going to do x plus x to a half times x minus x to a half. Okay, so we can, again, FOIL these together. That's 1/2. So we can do first outside, inside, last, or we can go difference of squares. Difference of squares, because these are conjugates. Okay. So if I go difference of squares, first term squared minus second term squared. First term squared is just itself. Now x to a half squared, remember the power rule of exponents? You multiply 2 times 1/2 and you get 1. So there is the answer to this one. That's pretty simple. X squared minus x. Let's take a look at enough multiplication. Let's review a little bit of division here. So for division, this time, for our division, let's say I'm going to divide a polynomial divided by a monomial, one term. So for example, suppose I want to do 15m cubed plus 25m squared plus 30m and divided by 5m cubed. Now to do this one, the way we divide by monomial is, recall when we add two fractions, a plus b over a over b plus c over b. Remember how we combine fractions with a common denominator? Well, if you look at the right side, isn't b a single term or simply a monomial here? So if I have a plus c over b, I can go in this direction and split it into two fractions, couldn't I? So A gets divided by B and C gets divided by B. Well, the same thing applies to what we're about to do here. I can break this into 3 fractions, this problem. 5m cubed over, 15m cubed over 5m cubed plus 25m squared over 5m cubed plus 30m over 5m cubed. You see that? That's an extension of adding fractions. So what are we going to do next? We're going to individually divide now. 15 divided by 5, that's 3. The m cubes cancel, so that's just 3. 25 divided by 5 is 5. Now I have 2 m's in the numerator, 3 m's in the denominator. Check this out. 2 m's on top, 1, 2, 3 m's on the bottom. When I cross these out, I just get 1 over m, or simply 1m in the denominator. Looking at the last fraction, 30 divided by 5, that's 6. And again, I have 1m on top, 3 m's on the bottom. One of the m's crosses out, so I get m squared. And there you have this one. The answer is going to be what you're looking at here. So that's a monomial, division by a monomial. Now what if I'm dividing by a binomial? So let's take a look at this other example, dividing by a binomial. So let's say I want to do m squared plus 4m minus 32, and I'm going to divide it by m minus 4. So how are we going to do this? M squared plus 4m minus 32 divided by m minus 4. We're going to do long division with these. Okay. Now in our college algebra class, we're going to learn a faster way of doing this, but for now we're going to have to do long division. So when we do long division here, or we can factor it actually. Okay, well, I'll do it both ways. Let's say if I factor the numerator, the factored form of the numerator is m minus 4, right, and m plus 8 divided by m minus 4. The reason is m minus 4. M plus 8 is because multiply 4 times 8, you get 32 negative. Negative 4 and 8 make 4. But we'll talk about these. In fact, this is called factoring. I just want to show that in case somebody said, yeah, why did he do it that way? He could have factored it. True. But we're going to talk about factoring in the next section, actually. And of course, here's the answer. So we already know answer is that using factoring. In college algebra, when we actually cover these later on, we're going to learn how to do this actually using synthetic division. But for now, let's do long division. When we do long division, you divide the first term in your dividend. Remember, this is your numerator or dividend. And this is your divisor. The divisor is the denominator. So I have dividend, just like in stocks, you get dividend, and you have a divisor. Now, we're going to divide the first term in the dividend by first term in the divisor. So that's going to be m squared by m. The result is m. Then I'm going to put that m up here above the fraction symbol, this fraction line. Here, this is what we call the quotient. Okay. And then we multiply the term in the quotient by both of these terms in the divisor. So m multiplies by m makes m squared. M times negative 4 is negative 4m. And we're going to now subtract. That's how the long division works with numbers, right? We then subtract this from the one above. Now when we subtract this from the one above, those cancel. Double negative on 4 makes positive 4m, and the 4m above that makes 8m minus 32. And then we're going to start this again. We're going to divide the first term in this. This is the remainder, by the way. Okay, so we're going to divide the first term in the remainder by the first term in the divisor. And that's 8. So we're going to add 8 in the quotient. We then multiply 8 by both of these terms of the divisor. So 8 times 8 is 8m, 8 times 4, 32. And we will subtract them just like we did over here. We subtract it from the one above. These add to 0. Double negative on 32 is positive 32, and 32 is 0. So this one actually has no final remainder. Now, we do this process of dividing first term by first term. Because this was 8m divided by, this process for as long as the polynomial that's in the remainder, this polynomial, if it has the same degree or more as the degree of the divisor, we continue. The moment the degree of the polynomial in the remainder is less than the degree of the polynomial in the divisor, then we stop. Okay, so that's the sign of when we stop. And you can see here the quotient, in fact, is the answer to the division problem. So the answer is going to be m plus 8, exactly the same as m plus 8 here. All right, so hopefully you could follow this one. That's how we do long division for these exercises. And let's do another one of these exercises, and I think that's probably good enough for our review here. Let's do one last example here. So suppose this time I want to do 3m cubed plus 5m squared negative 5m plus 1. I'm going to divide that by 3m minus 1. Okay, so let's set up our long division. It's going to be 3m cubed plus 5m squared negative 5m plus 1 divided by 3m minus 1. Remember how this process goes. First by first. First term by first term. First term in the dividend by first term in the divisor. So this will give me m squared. This becomes the first term, line it up with the first term here. With the same degree term in the dividend. But m squared is the first term in the quotient. We then multiply m squared by the divisor. So we get 3m cubed negative m squared. We then subtract this binomial that we just wrote from the entire divisor. Okay, that's why the other two terms, these two will carry over, because there's no like term to combine with them when we subtract. The first terms are opposites, they add to 0. Negative times negative is positive, so so this term is m squared 5 and 5m squared m squared, so that would be 6m squared negative 5m plus 1. Okay, got that one. And we will continue. See, as long as this is a remainder, as long as the degree of the polynomial, the degree is 2. is less than the degree here, which is 1, as long as the degree is greater than or equal to, we continue. All right, so next I'm going to divide 6m squared by 3m, first term in the divisor. That's going to be 2m plus 2m. And then multiply by divisor, you get 6m squared, negative 2m. And then we subtract it. Negative, negative is positive 2m, negative 5m is negative 3m plus 1. See, the degree of the remainder is 1. The degree of the divisor is 1. So we continue. As long as it's equal to, which it is right now, or greater than. Negative 3m divided by 3m. That's negative 1. So we're going to go plus 2m, and then let's go negative 1. Negative 1 times 3m is negative 3m, and see, I'm distributing again to the divisor. Negative 1 times 3m is negative 3m, negative 1 is positive 1. And subtract. These become opposite, and we have no remainder. The quotient in the long division, this is the quotient, is the answer to the division problem. So the ones we've done so far, the ones that I made up, so that there are no remainders. And there you have it. So hopefully, again, this is a quick review of polynomials for us. It's not an exhaustive review, it's just enough to recall some of the things. And we are done with this video and this lecture. Again, thank you for watching.